Hi guys, my name is Hector and today I will show you how you can declare your chassis in Lightning. So let's start. At this moment I'm recording this video, the only drivetrain that Lightning supports is the tank drive. Maybe you're asking what kind of drivetrain I am using. Well, probably the drivetrain that you're using is a tank drive. And what is the tank drive? Basically, it's the most common drivetrain that you will find in the vector robotics competition. Basically, it's the drivetrain that you have a left side, a right side with motors and wheels. Your chassis basically can move forward, backward, and make some nice turns. If you have another type of chassis, probably an Holonomic drive, just like an X drive or mechanical wheels, that means that your robot can move in all the directions. Don't worry because a new update from Lightning is coming soon. Going back to the drivetrain, basically you have a tank drive, it doesn't matter the amount of motors or wheels that you have, just if it's a tank drive, basically you can program it in Lightning. Basically, to declare chassis, you need to take the information about the drivetrain. Basically, what are the ports of the left side, what are the ports of the right side motors, the wheel size that you're using, if the gear radio that you're using, what kind of motors are you using. So you're using the green, the blue, or maybe the red ones. So let me show you how you can do that. So basically here in the Lightning documentation side you can find all the information that you need to declare your chassis. Let's follow the tutorial and I will show you how to code it. Basically, you're using a tank drive, you need to specify the odometry configuration that you're using. Exists different odometry configuration. You can basically don't use odometry, you can use odometry using the red encoders, or you can use an odometry with the V5 rotation sensors. So for example, if you're using odometry, you can set to the program if you're using just one tracking wheel, and if you're using with the red encoder or the V5 rotation. The same happen to the configuration of two tracking wheels with the red encoders or the V5 rotation, and also exists a true configuration that is basically you have your tracking wheels rotate. So I will show you how to declare each of these kind of odometry configuration in your code. One important thing to mention is that you need to have a EMU in your robot. Basically, what is an EMU? It's a sensor that will allow you to calculate the orientation of your robot. So it's important that you have it in your chassis. If you don't have a EMU, you cannot do basically a lot of functions. So please put the EMU in your robot. So to declare a non-odometry configuration, that means that your chassis doesn't have odometry. You can basically copy this declaration here and go into the Visual Studio Code. Basically, in your pre-example, you already have some declaration, but you can delete it. It doesn't matter. Just set your declaration, and if you check, you need to specify the Odom config you're using. In this case, we are using not Odom, and here we need to put the ports of the left side and the right side. Basically, you will notice that when you're using a chassis, your gears, your motors and wheels need to spin in a certain direction to move your robot. So keep that in mind. If you have more experience using pros or V5 code, you know that you can reverse the motor. So here that is necessary. If you want to reverse a motor, you just need to put this minus sign in the port. So for example, that means that the left side is all reverse and the right side is normal. So keep that in mind. Maybe in your chassis is different, so just check what motors need to be reversed. Then you need to set the IMO port of your chassis. Then you need to specify the gear set of your motors. For example, here I am declaring that you're using the blue ones, but you can, if you have a blue one, you can put just blue here. If you have red one, you can just put red, or you have the green, right? Then is the wheel diameter that you're using, so that is very easy. What is the diameter of your wheels? If you're using the 3.25 inches, maybe the 4 one, so just change this number to the wheel size. And then is the gear radio. You need to remember that is the result of dividing driving by driving the gears, so with that you can have this value. Well, if you need to declare a chassis that have odometry and just using one tracking wheel, using the red encoders, basically you can go here. This is the configuration. So basically you can just copy this declaration and paste it to your code. You will notice that in this declaration are different between the other configuration that we see before. That is because you're using the rain coders, basically you need to declare the ports that are connected. So basically the first thing is that you need to set the Odometry configuration. In this case is the One Odom. Everything remains the same, like, well, just these variables here. And then you have a new parameter. So basically you're seeing this, you have to say the physical configuration of your forward tracker. The forward tracker basically is the wheel that allows you to track the forward direction of your robot. And then you have the sideways. So you need to set the physical configuration of each tracking wheel in this constructor. So if you're using just one odometry configuration, so you're using just one tracking wheel, the sideways tracker, basically you don't need to set any variables. You just need to put a 0 here and just -1 and -1 to cancel this tracker. On the other hand, you're using one tracking wheel, you need to set information about that tracking wheel. So basically you need to put the wheel diameter of your tracking wheel and then the distance to the center. If you have already read some papers of odometry, you know that you need this variable. Basically the distance exists to the center rotation of your robot to this tracking wheel. Then for the tracker ports, basically you will notice that the red encoders, when you connect it to your brain, you connect it not to the smart ports, you connect it to the 3-wire ports. The 3-wire ports are labeled in 4 letters. So basically you have the port A, the port B, the port C, and so on. So you need to declare that port but with numbers. So basically if you are saying, for example, 1 and 2, that means that this red encoder is connected to the port A and the port B. One thing to keep in mind is you're using a red encoder. You know that when you connect the red encoder, you need to connect the cables together. So basically you cannot connect the encoder to, for example, the port A and the other cable in the port D, because it doesn't work in that way. You need to connect it together. So just keep that in mind. If you need to reverse the encoder, just put -n here in the ports, and that basically you're telling to the program that you need that encoder runs reverse. So basically if you want to use a chassis that has odometry with just tracking wheel, but in this case using the B5 rotation, you go in here to the rotation 1 odom, and basically you can copy this declaration over here. Then we just go to Visual Studio Code and then we just copy in this declaration. So you will find some change to the parameters. So basically the first thing that you will notice is that we need to change the DOM configuration. In this case we are saying that we are using the B5 rotation and we are using just one tracking wheel. In this case, just like the previous example, the sideways trackers need to be cancelled, so just put 0 in this case. The B5 rotation sensor, the port is a smart port, so it's just just a number. You don't need to put 2. So in this case, you will put the port of your B5 rotation sensor, and if you need to reverse, just put a -n right here. Just like the previous example, you need to put the wheel diameter of your tracking wheel and the distance to the center. Some important thing to mention is that basically having 2 tracking wheels is the most recommended because you have more accuracy. But in the past I used just one tracking wheel for a time drive, for space reasons, and works very well. Then if you want to clear chassis with a full odometry, that means that you have 2 tracking wheels, just like in this example. So you're using the B5 rotation sensor, you need to use this declaration, the rotation 2 odom, but if you're using the red encoder, basically you're using the AD2 odom. So well, for the red encoders we just need to copy this declaration. So we just need to move to the Visual Studio Code and copy this declaration instead. So you will find the thing that change is that you need to set this configuration, basically the AD2 odom. You need to set information, but not only for the forward tracker just before, you need to now to put the sideways tracker information. So basically it's the same. You set the wheel diameter and you set the distance to the center, and you need to put the ports. In this case, for example, we are telling that this forward tracker is connected to the A and B port and need to be reversed. The second tracker, that is the sideways, basically is connected to the -3 and -4. That means that it's connected to the port C and D and it's reversed. If you don't get it, what is the forward tracker and sideways tracker, is really easily. Basically, going here, this tracking wheel is the forward and this tracking wheel is the sideways tracker. Then if you are using the V5 rotating sensor, just going here, we will copy this declaration, moving to the Visual Studio Code, and then we just will copy this declaration right here. Oops. Well, after that accident, basically you will notice that we changed this Odometry configuration to specify that it's a rotation with 2 odom. Basically everything remains the same, but in this case you are initialize the sideways tracker, put in the port that is connected, the wheel diameter, and the distance to the center. Usually when you have 2 tracking wheels, basically you have like the same wheel diameter and basically the same distance to the center, but well, you can change it if you need it. Basically the other thing is to remember that the V5 rotation sensor is connected to the smart port, so just put, for example, the forward tracker will connect to the port 1 and the sideways rotation will be connected to the port 2. And if you need to reverse, just put a negative sign and everything will be okay. Then exists this configuration is when your tracking wheels are rotated. Doesn't matter you have the ADI encoder or you're using the V5 rotation. Honestly, this configuration looks pretty dangerous and it's pretty cool. The reason why it works is because it doesn't matter that the wheels are rotated, because these tracking wheels are perpendicular each other, so that is the reason why it works. So basically, if you want this Odometry configuration, basically just going to Visual Studio Code. So the example is for when you have full tracking wheels. So you want to rotate it, just change to specifying that it's rotated. So just will be this to rotate odom. Basically, you have another declaration that's said before when you have the ADI encoders, like in this example right here. So you have everything okay because you are specifying the forward tracker and the sideways tracker, and just change to ADI rotate odom. If you're using the 2 rotate tracking wheels, it doesn't matter if you're using the red encoders or the V5 rotation, you need to set what amount of degrees your tracking wheels are rotated. So basically, to do that, you just go to the initialize function and put my chassis, set the odometry rotation, and put the amount of degrees. In the previous example that we show you in this image, these wheels are rotated minus 45 degrees, so I will just put that amount of degrees. If you're not using that configuration, you're using the normal odometry, it doesn't matter if the 1 tracking wheel or 2 tracking wheels with the red encoders or the V5 rotation, you don't need this function. Once that you clear chassis, you can start using all the lightning function, start programming the drive period controller, and also the terminus function. Maybe it's kind of tedious to declare chassis, but don't worry, because basically you are telling to the program the relevant information that you already know. So don't worry about it. If you're using a chassis that doesn't have odometry, you can use some function just like pure set planning, moving to a point, but don't worry because you can still using a pretty good function that will allow you to program the tournament routine. In the following tutorials, I will show you how to program the drive period. So basically, each tutorial you can use it and you can follow it independent of what kind of drivetrain that you're using. But in some episode, I will show you some function that just drivetrain that has odometry can do it. But I will warn you about it. They will